So good morning. So in yesterday's class, we were discussing regarding the system devices and drives. We started with module 2. So where we discussed two types of motors. One is called a hydraulic motor, another one is a pneumatic motor. So we discussed what are the different types, what is the basic principle of working of a hydraulic motor, and what are the different types of hydraulic motor. And also similarly, we have it for the pneumatic type of motors and their types and their working principles and their advantages and disadvantages. In today's class, let us start with the third type of motors, what we call it as electric motors. Okay. So in these electric motors, we will going to discuss what is the principle, what is electric motor, and what is the basic principle of operation of electric motor, and what are the types of electric motor, and how these electric motors will work. So this is what we will going to discuss it in today's class. Okay. Let us start now. So now, introduction to this topic. First question is, what is an electric motor? Basically, electrical motor is an electromechanical device that converts electrical energy to mechanical energy. So this mechanical energy, we will use it for rotating the pump, impeller, fan, blower, drive compressors or lift materials. Of course, there are plenty of applications where we use the mechanical energy. And this mechanical energy is obtained from the electrical energy. So this conversion of electrical energy to mechanical energy, which is used for various purposes, is what we call it as an electric motor. Okay? So in most of the 70% of the motors used in an industry is an electric motor. Okay, so wherever you go, so you are going to see this electric motor for serving many purposes. Okay. So this we will going to discuss it now, one by one now. So now, what is electric motor? Basically, it is electromechanical device which converts electrical energy to mechanical energy. Okay. So now, what is the basic? How it converts? What is the principle of operation of this electric motor, and what makes the device to convert the electrical energy to mechanical energy? This is what we are going to discuss under the principle of operation or how electric motor works. The electric motor works on the magnetic principle. I think you might have studied these concepts in your physics or electrical sciences. See, basically, the electric motor works on the principle of electric current produced due to the magnetic field, or in the reverse way. If electric current passes through the magnets, so it experiences a magnetic, whatever it might be. So here, so when you look at this sketch over here, so there are two magnets. An electric current in a magnetic field will experience a force. So two magnets. So when you place a conductor through which the current is flowing, so when it comes in contact with the magnetic field, it experiences a force. I think this you might have in with different laws also. Some right hand thumb rule or left hand thumb rule, whatever it might be. So I think you might have studied these things in your physics or electrical science. So this is the when an electric current passes through, when an electric current in a magnetic field will experience a force. This is the one important thing you're supposed to remember. Now, if the current carrying wire is bent into a loop, this is only a single current, single conductor or a single wire. So now, if this wire has been bent into a loop in this way, just look at here. Okay, then the two sides of the loop, which are at right angles to the magnetic field, will experience forces in the opposite direction. Okay, so the two sides of the wire, which are bent into a loop, which are exactly at right angles to the magnetic field, and these two sides will experience a force which are in opposite direction. You can see, so across the North Pole, the force is in the upward direction. Across the South, the force is in the downward direction. what does it say? Two equal and opposite forces. The pair of forces which creating a turning influence or a torque which rotates the coil. This is the basic principle. So when two equal and opposite forces are acting, which will constitutes the turning force or turning influence, or we generally term it as a torque. And the effect of torque is to rotate the coil. This is what we are showing over in this diagram over here. You can see here. So the coil is the rotating because of the two equal and opposite forces acting on the coil. Okay. So practical motors have several loops on an armature to provide a more uniform torque, and magnetic field is produced by an electromagnet arrangement called the field coil. So this is the basic principle over which the electric motors work. In the sense, what we see the electrical motors, these motors will have several loops of these coils which will be wound on the armature. And the armature will provide a uniform torque. And the reason for getting a magnetic field is an electromagnetic. So when current is passing through a conductor, and you are going to get an electromagnetic arrangement, and that is called the field coil. So this is the basic principle of electric motor in the sense. So when a current in a magnetic field will experience a force, and when that wire has been bent into the form of a loop, so the opposite sides will experience the forces in the opposite direction, and these two equal and opposite forces will constitute a turning influence, or what we call it as a torque, and the effect of torque is to rotate the coil. Once the coil will rotate, so along with that, the rotor will also rotate. This is the basic principle of the electric motor. Okay. So similar thing we are having over here also. Look at this also. So when electric current passes through a coil in a magnetic field, the magnetic force produces a torque which turns the DC motor. So this is the one what we are having over here. See the current flowing in this direction. See? So based upon the direction of the flow of current, the force will be induced, and these forces will be acting exactly opposite to each other in the direction. They are equal in magnitude but opposite in direction, and that will constitute a turning error, which causes the turning of the coil, so which we generally call it as a torque. Okay. So the magnetic force F is calculated as I into L into P, where I is the current, L is the length of the coil, and B is the magnetic. This is the one direction what it is going to. Okay. So this is what we call it as the electric work, how electric motor will be going to work. Now comes the basic classification of electric motors. The electric motors are classified into two main categories. One is called alternating current motors, or short we call it as AC current. Second one is called direct current motors, or DC current motors. And of course, across alternating current motors, we have a synchronous and induction type. And within the induction, we have two types. One is called single phase and two. And moving on towards the DC motors or DC current motors, we have separately excited type and self-excited type. And across self-excited type, we have series, compound, and shunt. So this is the basic classification of electric motors. Broadly classified into AC motors and DC motors. Of course, within AC and DC, we have separate classification. We will going to discuss this in brief now, one by one. Let us take AC motors. Alternating current motors use an electrical current which reverses its direction at a regular interval. So this already we know. So alternating current means it will keep on changing its or reverses its direction at across the regular interval. That is what we call it as an alternating current motor or AC motor. An AC motors has two basic electrical parts. One is called a stator, another one is a rotor. Yeah, so this is the one what we can see here. This is the rotor and this is the stator. So stator is the stationary electrical component, whereas the rotor rotates the motor shaft. So the basic principle is, so the basic what I discussed the principle over here. So as the current passes through this coil which is mounted on the status, so it will start creating the magnetic field and it will create a turning effect which causes the rotor to rotate. The same principle we would talk about for AC motors also over here. Okay. So here we have synchronous motors. So two classification of AC motors. One is called a synchronous motor, another one is called induction motor. So what is synchronous motor is? A synchronous motor is a AC motor which runs at constant speed fixed by frequency of the system. This motor rotates at a synchronous speed which is given by the equation. This is the expression what we use it for calculating the speed, the synchronous speed, 220 F supply frequency to the number of poles. Basically, so at what frequency you are providing the electricity current. This is a very important. So this type of motors will rotate at a constant speed fixed by the frequency of the system. So how much amount of what is the frequency at which the system should run? So that will be fixed by that fixes the speed, and that this type of motors will run at that particular speed and it maintains the speed at a constant level. So such type of motors we call it as synchronous. Okay, so we can calculate the synchronous speed by using this formula. And next type of motors is induction motors. So these are the common type of motors we use it in for various equipments. So look at this different parts of this induction motor, rotor and a stator. Okay, so when you come over the stator, so look at this is the stator stationary part and rotor is the rotating part. So it will have a blades or a fan blades bearing on each end, rotor electromagnets, everything is wound over here. Okay, so the stator electromagnets. So motor frame. So this rotor will be placed inside the stator, and as the electric current passes through this, because of the current passing through that rotor, because rotors will have coils wound over it, and of course even stator also it will have inside coils. So as the magnetic field experiences the current experiences the force due to the magnetic field, so it will create the torque. So that torque will causes the rotor to rotate. So once the rotor rotates, rotor is connected to the shaft. So the shaft will go into rotate. So the rotation of the shaft will result in the mechanical energy. So that mechanical energy can be used for different purposes, what we discussed in the first class. So this is the basic induction motor, how it works. And again, induction motors are classified into main groups: single phase induction motor and three phase induction motor. And in the case of a single induction motor, this will have only one stator winding, operate with a single phase supply. Whereas three phase induction motors, they will have three sets of stator coils that rotate, magnetic field drags the rotor around. So the basic classification is single phase works on a single phase power supply, whereas three phase works on the three phase power supply. The principle will remain same. So only in the case of a single phase induction motors, you will have one stator winding, whereas in the case of a three phase, we will have a three sets of stator coils, and which will rotating the magnetic field drags the rotor around it. So it will have more power than compared to that of the single phase induction motor. These two types of AC motors. Next comes the DC motor. A A DC motor is an electric motor that runs DC motor is an electric motor that runs on DC current or direct current electricity. The two types of DC motors, one is brush and brushless DC motor. So the motor which runs on DC current, we call it as a DC motors. Okay, and there are two types of DC motors. One is called a brush, another one is a brushless DC. So what do you mean by what is the difference between these two? Brushed DC electric motor generates torque directly from DC power supply to the motor by using internal commutation, stationary magnets and rotating electrical magnets. In the sense, the brushed DC electric motor, so in which the torque will be generated directly from the DC power supply, and this generation of torque takes place by using internal commutation, stationary magnets, which may be permanent or electromagnets, and rotating electrical magnets. All these three components will involve in the generation of torque directly from DC power supply to the motor. So such type of motors we call it as brushed DC electric motors. Then the second type is what we call it as a brushless DC motor. So these type of motors use a rotating permanent magnet or a soft magnetic core in the rotor and stationary electrical magnets in the motor housing. In the sense, in the case of a brushless DC motors, the rotating permanent magnet, the rotor consisting of a rotating permanent magnet or a soft magnetic core, whereas the stationary electrical magnets in the motor housing. So using these two things, the brushless DC motors will generate the torques. So this is the basic difference between the brushed DC motor and brushless DC motor. Okay. Yeah. So let us look at another one slide over here. DC motor, as the name implies, use a direct unidirectional current sources of electricity, whether it might be a batteries or DC power supply. Okay. When power is applied, DC motors turn in one direction at a fixed speed. They are optimized to run at a fixed, usually high RPM. Torque is the highest at the rated speed and lowest at the low speed. Almost all can be reversed, inexpensive and commonly available. So in this case, when current passes through or when you supply a power, so this DC motors will turn in one direction and it will turn at a fixed speed. And they are optimized to run at a high speed or a fixed RPM or usually at higher RPM. And torque will be maximum at the maximum speed and it is the minimum at the lowest speed. Okay? And they are inexpensive and it is commonly available. A type of motor. So when it comes to the DC motor components, so we have three important parts. One is called field pole, armature, and commutator. So field pole means North Pole and South Pole, and they receive electricity from magnetic field to form magnetic field. They receive electricity to form magnetic field, the field poles. And field poles are two types. One is North and South Pole, and once it receives electricity, it will form the magnetic field. And next comes armature, cylinder between the poles, electromagnet when current goes through, linked to a drive shaft to drive the field. Very simple here. The armature is act as a cylinder between the two poles, North and South poles, and it will become an electromagnet when current passes through it, and it is connected to the driver shaft to drive them. It is the armature. Armature is the rotor component here. It is a rotating component here. And commutator overturns current direction in armature. This is the three important parts of a DC motor. The main advantage of DC motor is the speed control without, just a minute. Yeah, speed control without the impact power supply quality. That is, the changing armature voltage and changing field current. So here, speed control without impact power supply quality. So without impacting, the one of the major advantage of DC motor is you can control the speed without having an impact over the supply quality. So this can be done by changing the armature voltage and changing the field current. So both can be done for changing or controlling the speed without having an impact over the power supply quality. And second one is suitable for turning and swinging, etc. And it is restricted to use few low, medium speed applications, still and non-hazardous, expensive compared to DC motors. So then comes the classification or the types of DC motors. The classification of DC motors depends on the way of connecting the armature and the field winding of a DC. In a sense, the way in which you are classifying the DC motor is based upon how the armature and the field winding are connected. Armature and the field winding are connected. So based upon that, so there are three types of DC motors. One is called a DC shunt motor, DC series motor, and third one we call it as DC compound motor. So of course, across DC compound motors, we have two subclassification. One is called short shunt compound, and second one is called long shunt compound. Of course, across short shunt compound, we have again two classification. One is the cumulative compound motor and differential compound motor. In the similar way, the long shunt compound is also been classified into cumulative compound motor and differential compound motor. So this is the basic classification of DC motor. This is very important from the examination point of view. Please prepare for this very nicely. Okay. So this classification is based upon how the armature and the field of winding will get connected. This is the classification of a DC motor. Now let us start with one by one. So DC shunt motor. In DC shunt motor, the armature and field windings are connected in parallel across the supply voltage. In DC shunt motor, armature and the field windings are connected in parallel across the supply voltage. So in the sense, so what we were talking in the previous slide is the way in which the armature and the field windings are connected. So we have a shunt motor, DC shunt motor. In a shunt motor, what happens? The armature and the field windings both are connected in the parallel across the supply voltage. In the sense, both armature and field windings are connected in parallel across the supply voltage. The resistance of the shunt winding, RSH, is always higher than the armature winding. So when you look at here, so this is the circuit what I am showing over here. This is the supply voltage. Okay, so this is the armature and this is the field winding. Okay, so armature, this is M, armature and the field winding both are connected in parallel. The resistance of shunt winding, RSH, is always higher than that of the armature winding, RE. Since voltage and shunt winding resistance, both remains constant, the current through the shunt resistance remains essentially constant. A field current is responsible for the generation of the flux. Thus, the magnetic flux is directly proportional to the current flowing through the shunt. shunt motor is also called a constant flux motor. The magnetic flux, what it is being generated, that remains constant. Hence, the shunt motor is also called as a constant flux motor. So please remember. Okay, so this is the how DC shunt motor works. Next comes applications of a DC shunt motor. These motors are constant speed motors, hence used in the application requiring constant speed, like a lathe machine, drilling machine, grinders, blowers, or compressors. So this is, of course, we use the DC shunt motors in where the speed needs to be very constant for us. So in such cases, we will use the DC shunt motors. That is especially in the case of lathe machines or drilling machine or grinders or blowers or compressors. Okay. Then the second type of DC motor is a DC series motor. In this type of motors, the armature and the field windings are connected in series across the power supply. Okay. The resistance of the series field winding RS is much smaller than the armature resistance RA. That's the diagram over here. You see here. See, in this case, what happens? DC series motors, the field windings and the armature. So this is the armature here for you. This is the armature. Armature and this field magnetic field or field windings, we can call it as field windings. They are connected in series. You can see this is the connected in series. Okay. So resistance of the series field winding RS is much smaller than the armature resistance RE. So this resistance of this field winding is very less compared to the resistance of the armature. Thus, the flux produced is proportional to the field current, but in this case, IF is equal to IA, thus I is equal to IA over here. In the sense, the current flowing through the armature. Okay, so the flux, the magnetic flux, what it generates is directly proportional to the current flowing through the armature. Thus, flux can never become a constant in DC series motor as the load changes. IF and IA also gets changed because once the load changes, okay, as the load changes, so you will going to get both the IF and IA both will going to change. When IA and IF both will going to change, then the flux will never remain constant. So therefore, in the case of a DC series motors, the flux can never become a constant. Okay. So therefore, in this case, the DC series motor is not a constant flux motor, whereas the DC shunt motor is a constant flux motor, whereas the DC series motor is not a constant flux motor. Please understand this circuit diagram over here. And coming to the applications of this DC series motor, these motors are useful in applications where starting torque required is high and quick acceleration. In the sense, wherever you need starting torque is very high and we need it need to be accelerated very quickly. So in such cases, we use for example, in the traction, where the initial torque should be very high, hoist and lifts, cranes, rolling mills, or conveyors. So these are the typical applications of DC series motor. So in all the applications, when you look at that here, so here the initial torque will be very, very, very high, and it needs the quick acceleration. The acceleration should be very, very fast. It needs to be taken very fast. So such type of applications, you can find it in the form of crane or rolling mills, or in the case of conveyors, and even hoist and lifts, where you are lifting the heavy loads, and even in the traction. So where you will find the torque, initial torque should be more. In such applications, we will going to use the DC series motor. And the last type in here is DC compound motor. See, the DC compound motor is a combination of the series motor and shunt motor. It has a series field winding that is connected in series with the armature and shunt field that is in parallel with the armature. The combination of series and shunt winding allows the motor to have the torque characteristics of the series motor and the regulated speed characteristics of the shunt motor. Several versions of the compound motors are there. This DC compound motor basically, it is a combination of a series motor and a shunt motor. So what happens in the shunt motor is the field windings are connected parallel to the armature, whereas in series motor they are connected in series with respect to the armature. So we find the speed remains constant in the case of the shunt motors, whereas in the case of a series motor, so you are going to get very high initial torque and more acceleration. So now when you combine both these two, since one is a shunt motor and a series motor, in such a way that the series field winding that is connected in series with the armature and shunt field, series field is connected in series with the armature, whereas shunt field that is in parallel with the armature. The combination of series and shunt windings allows the motor to have both the characteristics of torque characteristics of the series motor as well as the regulated speed characteristics of the shunt motor. Okay, this is what we call it as a DC compound motor. Of course, these DC compound motors are of two types. One is called a short shunt compound motors. Second one is called long shunt compound motor. So what is this short shunt compound motor is? When the shunt field winding is connected in parallel with armature like DC shunt motor, and this assembly is connected in series with the series field winding, then this type of motor is called a short shunt compound. In the sense, when the shunt field winding is connected in parallel with the armature like DC shunt motor, and this assembly is connected in series with the series winding, then this type of motor is called as a short shunt compound motor. And depending upon the polarity of the connection, short shunt motor is classified as cumulative compound motor and differential compound motor. So let us look at the sketch over here. See what's happening here. It is a short shunt. Short shunt in the sense, look at here. The shunt field, short shunt field is in connection, is in parallel with respect to the armature. Okay, so you are connecting short shunt field parallel to the armature, which in turn is connected in series with the series. So such type of field, what we call it as the short shunt compound motor. Okay, where the shunt fielding winding is connected in parallel to the armature, see, parallel, and this is connected in series with the series. This is called short shunt compound motor. Okay. Next comes the long shunt compound motors. So in this case, when the shunt field is connected in parallel with both series field and the armature, then this type of motor is called a long shunt compound. So again, depending upon the polarity, in the sense we have two types. One is called a cumulative compound motor and differential compound motor. See what happens in the case of a long shunt compound motor is the shunt field is connected in parallel to both series field and the armature. Then that will constitute long shunt compound motor. So let us look at the circuit diagram here. Look at here. So this is the long shunt field, very long shunt field here, and it is connected in parallel with the armature and with respect to the series field. So this will constitute the long shunt compound motor. Long shunt compound motor. This is the one what you're supposed to remember in this case. Okay, that is the difference between a short shunt compound motor and the long shunt compound. Next, coming to the application of DC compound motors. So we have a cumulative compound motor. These motors have high starting torque. They can be operated even at no loads, as they run at moderately high speed at no load. And hence cumulative compound motors are used for following applications: elevators, rolling mills, punches, shears, and planes. In the sense, cumulative compound motors will have a high starting torque, as in the case of a series motor, DC series motor. And these type of motors can also be operated at a no loads, because they run at a moderately high speed at no load. And hence they have been used for elevators, the rolling mills, punches, shears, and planes. This is the application of cumulative compound motor. Next, when it comes to the differential compound motor, the speed of the motor increases with increase in the load, which leads to the unstable operation. Means the differential compound motors where the speed of the motor increases with the increase in the speed, and hence which leads to the unstable operation. In this case, what happens? The speed is directly proportional to the load. So as you increase the load, the speed will also going to be increased. So therefore, we cannot use this kind of motors for any practical application, because we cannot have a control over the operation, because the operation will become totally unstable for us. So this is what we call it as the DC motor, compound motor. So this completes the electrical motors. So students, so if you have any clarification, you can talk to me. Okay. So today we will be having a test at 12 o'clock. And similarly, you have additive manufacturing at 6 o'clock today. It has been postponed yesterday, it's supposed to be have. So attend the test. Yeah, all the best. In the next class, means next week, we will going to start with the actuators. So first part of the module 2 has been completed today. Only the second part is there. So that I will going to take up in the. Anybody anything to ask?